In this video, I'm going to solve exercise 14, page 93. Given a right isosceles triangle ABC, so that AB equal AC equal A. So we are given this right isosceles triangle. Construct the vector AD equal AB plus AC and calculate the norm of AD. So we have AD equal to the vector AB plus AC. So let's draw vector AB and vector AC. Notice that the two vectors start from the same origin, A. So since they start from the same origin, to find the sum AB plus AC, we have to use the parallelogram rule. So by the parallelogram rule, AB plus AC is equal to AD, where D is the fourth vertex of the parallelogram ACDB. Okay, so let's draw D. Of course, here the parallelogram is a particular case of a square. So let's draw vector AD such that D is the fourth vertex of the parallelogram, which happens to be a square. So this is point D. So we're done with the first part, but we need, of course, to write the explanation. In the second part of the question, we want to calculate the norm of vector AD. Okay, so let's complete this to get a square. Notice that AD as a norm is equal to the norm of vector BC, or equal to the length of segment BC. So because we know that the diagonals of a square are equal, so we have AD equal to BC, and since ABC is a right isosceles triangle, we know that the hypotenuse is equal to the length multiplied by radical 2. If you don't know this rule, or if you don't remember it from grade 9, you can simply apply Pythagoras theorem and say BC squared equal CA squared plus AB squared, and then solve to get the length of BC. So we can do both. So we write AD equal BC. The reason is that the diagonals of a square are equal. And we know by Pythagoras, we have that BC squared is equal to BA squared plus AC squared, which is equal to A squared plus A squared, which is 2A squared. Hence BC is either plus or minus radical this, but since we know that the length is positive, then BC is equal to A radical 2, and therefore AD is equal to A radical 2, and the norm of AD is A radical 2. And as I said before, if you don't want to apply Pythagoras theorem, you can simply say that it's A radical 2 because it's a property of a right isosceles triangle.